is a field that helps us understand how microbes like bacteria and viruses interact with humans, often leading to diseases, and how science can fight back. It is a subject that is more relevant today than ever. Hello, everyone. I am Manya Chawla.
And I'm Ipshita Singh, and we are the members of the outreach team of Eureka. And today we are joined by a very special guest, Dr. Ishan Pandey, to discuss about the topic of infectious biology.
Sir, firstly, thank you so much for taking your time to join us today. Uh, to begin with, could you please tell us a little about yourself and your journey into the infectious biology field?
Yes, I did my graduation in biological science, basically life sciences, and my subjects in the final year was zoology and chemistry. So I had some biochemistry background and some zoology or the animal biology background. So relating into it and being involved, and I wanted to become a physician or a doctor first thought after doing 12th with biology, as most of the aspirants thought of after taking biology they want to become a doctor, but it's just a blessing in disguise, or it's something, we call it destined, that I just
Hmm.
landed to this biological field. And then I suddenly got interest. And in my final years, when I was studying this animal biotechnology or biochemistry, then there was a lot of boom about biotechnology in the year 2007 and 8 when I was in my final year of my graduation. So every now and then I used to read newspapers, newspaper cuttings. They used to have this genetic engineering, biotechnology, diseases are being eliminated by lots of genetic tools are being developed, and biotechnology was so much new that we'll develop organs will be developed, and lots of things were in talks. So I got interested into biotechnology first. So it is a very interesting story. And I started filling forms for biotechnology, JNU, biotechnology combined entrance, and other universities which were central universities for entrance exam. Because mostly at that time in 2007 and 8, around this uh, 17 and yeah, 18, 15 to 15 plus years ago, there were not much universities and colleges. They were having postgraduate programs in biotechnology or this kind of field. So I wasn't aware of microbiology as such, but then by giving exams and then by I visited some, like I visited JNU and Delhi University just to see some labs, and I got more interested into it. Then I filled forms, and suddenly what happened in one university, there was option to fill two other branches apart from biotechnology. So my option I filled was microbiology and environmental science. So what happened was that I returned, and one of my friends, whose father was a medico, he's a doctor of dermatologist. He was an HOD. So he told me that okay, you can take biochemistry and microbiology, and since you were preparing for MBBS exams, you can become a teacher in medical college, because I was not knowing about that you can do MSc in microbiology and you can become a demonstrator or a tutor and then start your career as a faculty in medical colleges in preclinical and paraclinical subjects. So he said that, but he said that don't take biochemistry because it is a non-clinical subject, and you will face lots of hurdles and challenges. Rather, microbiology is a good subject, and you will have lab exposure and other things. You can take it. So I was more of interested, and and when I was opting for biotechnology, by default, there was just one first waiting in my free seat category for biotechnology, and I was the first candidate admitted in MSc microbiology for the free seat
Oh,
or seat in my university. So I took that. There was an option for second counseling, but that line from my friend's father was always at the back of my mind. I thought he also said that okay, environmental science is also good. You can have good scope in that also, but microbiology, since you are more interested into medical field, and that one liner he said, na, that if you don't worry if you haven't become a doctor, you can teach doctors. You can teach the medical professionals. That was striking in my mind all the time. So I just, and since I was interested in medical science, so I was always inclined towards medical microbiology aspect. So during the course of my MSc microbiology with summer internships, like you all students also do, I went to Jalma. There is ICMR Institute in Agra. I went for 1 month training there. Orientation course was there. Then I trained in my medical college at Prayagraj for 20 days. Then in the final semester when there was dissertation project. So for that I applied in Lucknow. In, for CSIR, CDRI I applied. I applied to NCCS Pune. I applied to SGPJ, which is a Institute of National Importance. It is PGI in Lucknow. So I applied there also, and luckily I got a seat there. So it was WHO National Polio Surveillance Lab. That was northern India, means Bihar and UP. Those were the only states which were not polio free at that time. So there was a project from CDC, WHO. They were all investing huge amounts. So the lab was very much resourceful. So I entered into that, and during that dissertation time, I got to work on non-polio enterovirus, because that also, like I said earlier, na, that it is destined, or you just all the circumstances takes place for you. So everyone was working on polio viruses, but my boss suddenly said that no, okay, you don't work on polio virus, you work on non-polio enterovirus, because those are also prevalent in the samples. And he said that went to Itai Hitachi Institute, Japan, Nagoya, Japan. From there, I have got one ECO11 virus sample. ECO11 is enterocytopathogenic human orphan virus. So he said that take that ECO11. You know everything about ECO11. Now you have to test those samples that are being reported in our lab from UP and Bihar states, and you have to check whether you can find similar samples in. Means there was a comparative study with TCID50 and all these comparisons. You can see whether you can find any similarity with any other strain. If some other strains are looking similar for it. So that's how gradually I did my dissertation at work. So at that time, being a master's student, I was not much aware about research and publication and thesis. It was just I like that I have to complete my dissertation. I have to go to my university, present, get my PG degree, then land up in some job. So that is a common tendency, because other friends are also there. Some are working in agriculture biotechnology in CMAP or NBRI, other institutes. Some are working in Delhi. So it is just like that you have to complete our project and just finish and come back. But I didn't knew at that time that because there was not much exposure. So my boss said that you cannot publish. You have to just present your data. You just keep your thesis over here. I was not aware of what will be going to happen. There was 2 3 viruses which were having quite a similar value and all. Cell culture was there. Means the cell lines were brought from CDC Atlanta, Georgia. So it was CD155 cell lines, expressing cell lines, and there were the ecos this RD cell lines were there, L20B cell lines were there. So I worked on that. I even at, at the time of masters, I wasn't even aware that I'm working on cell lines. Will that be fruitful in my career? Now think people say that okay, you have worked on cell lines, you can work on that, blah blah. So I wasn't aware of it. I just kept on working on it. After my masters, there was a department of medical genetics also there in SGPJ. So I had few senior friends. I used to go there also. And at that time in 2009-10, there was an outbreak of swine flu. So, the swine flu was there. So some people also started saying, oh, don't work in microbiology. It is highly contagious. You can get, I got some offers for PhD also for tuberculosis. So that was also because some few of my friends said that India is the tuberculosis capital of India. Don't work, because if you work for 5 or 6 years for your PhD, more than 3 years, it is high chance that you're going to get infected. Even in Jalma, Agra, ICMR, I was working. There also they used to be very stringent that you should have your breakfast, you should come with all your equipment, PPE equipment, because you can get infected very easily because it is a BSL-3 facility. So that is how I got interested into the subject, and likewise I ended up working. Then, as I told you, I went to genetics department. They were working on cancers. So oncology was also a field that jokingly people used to say that what is cancer? They say that it produces 5 PhD theses in a year. So cancer biology is something which gives you 5 PhD per year. So different kinds of cancers. So I got interested. Then suddenly, my probable PhD supervisor, she is a pathologist at my place in my college. I thought that, I mean, look, you work in AIMS, you work in PGI. I have got that exposure. You work in ICMR. You get lots of facilities, but for you to explore, you need sometimes you need a B category institute as well to make yourself more equipped or more advanced. So it is rather, you can take it both ways. Sometimes you are working with a king, you are having each and everything, but sometimes you get overshadowed because there are lots of seniors, everyone, the lab is established. You have nothing to experiment, you have nothing to explore, you will just go with the flow. But if you work in a B tier institute, from setting up a lab to getting your samples to uh, having searching for all the instruments and collaboration, outsourcing, lots of things you have to juggle. You have to do the office work also. But what happens is that you get to know much more things, and you may make yourself more equipped, or what you can say about the skills, you get more skillful in your journey. Because after PhD, what happens is that if you work in a system that is totally designed, you just cannot think beyond that. You just think that, okay, my boss told me this. This was my lab routine. I used to present my journal club. I used to do this, blah, blah. And you cannot think out of the box. So that was my take, and I went to my boss. She said, "Okay, I work on." She was a pathologist. I work on cancers, but I don't work on microbiology. You can go to microbiology department. But I said, "No, no, I want to work with you." Then she said, "Okay, I work on gastric cancers and H. pylori." So H. pylori is a gut pathogen. It is causing gastric cancer. It is well known. Human papilloma virus is there. So luckily, what happened is she told me that will be H. pylori will be your microbiology, and gastric cancer, stomach cancer will be oncology. So we can club it together and we it for a topic. So I took that. Meanwhile, I was working on it. So I was teaching in different universities. I was taking classes for diploma in medical lab technology in my medical college for my funding resources. And suddenly she had one project also that was an Indo-European project with all the European countries and uh, cities in India, which is north, south, east, west, all they were collaborating. So that was on HPV virus and cervical cancer, head and neck cancers, oral cancer. So that also came as a part of my virology expertise. So I joined it as a research assistant as well. So it is just shaping up, and I'm getting exposed to everything. So I worked on both projects simultaneously. For my PhD, I worked on gastric cancer and H. pylori, and for my this financial things, I worked on a project, funded project of ICMR and EU, that was on HPV and head and neck cancer. It was having main office at RGCB Trivandrum, so that was the main office of that. So that is how I worked on it, and when I completed my PhD. During that time, COVID also came, and my wife is working at Center of Biotechnology, Allahabad University. She was working on mushrooms. So she was working on mushroom, and mushrooms are macrofungus. She was in Center of Biotechnology. So at that time, she was working on herbal products or mushroom-based products, and slowly I got interested into that global area of AMR, antimicrobial resistance. So antimicrobial resistance, which was thought, means it is thought that 2050 will be a silent pandemic. So
Mm.
AMR is spreading so much, and it is causing a lot of concern. So for that, newer alternatives, and she was working on that only. And she was using not about drugs. She was using functional food, as mushrooms are having much more bioactive compounds. It is having vitamin D. Means it is much more unexplored. And in during the times of COVID, when it came, our prime minister also said that the Ayush or the Ayurveda, our ancient science, that needs backing from our scientists, our professionals. We need validation and scientific evidence. We just can't say, because in our country or in the Western country, they used to say that this is a pseudoscience. Homeopathy or all the other alternative medicine, they are pseudoscience. So what we need is that, like modern medicine, we need scientific evidence and publications or research that could prove that really they are having some medicinal values or properties that are responsible for drug development or other. So that is how in COVID we started publishing and working on that area also. And meanwhile, when in my PhD, I was having one of my colleagues, she was working on nanotechnology based wound dressing on diabetic wound healing. So I had some collaboration on nanotechnology and wound healing as well. There also means overall, just wherever there was microbiology, I got some much interested because there were antimicrobial wound dressing was there in uh, diabetic ulcers. So that was a project she was having collaboration with IIT Kanpur. So I worked on that also, but that was not directly linked to it. I worked with some few papers and some reviews, etc. So that is how my journey came, and after that, I'm working with different organizations as a faculty now, as a scientist. Now, uh, at present moment, I am having one project with myself also. That is on. It is a nutraceutical quercetin, like curcumin. You might have heard about curcumin, which is present in this haldi. It is present. So that is how there is curcumin, this quercetin, berberin, lots of antioxidant, resveratrol, different kind of antioxidants. So they are being used as an adjunct therapy in different kind of cancers. So for that also, standard of care chemoradiotherapy is being given to oral cancers, and now I'm using quercetin as a adjunct therapy to decrease the side effects of cancer therapy, the standard of care, and also to see if that quercetin is having some effect on P53 based genes or down regulating it or up regulating it. What is the effect of this quercetin on P53, which is the guardian of human genome, and it is very well known to prevent the cancers. So that is how each and every day I'm much more interested into One Health approach also. Like your questions were also like that, what is how this global climate change and all things are. So now it's an era of collaboration. Bioinformatics is there, AI is there, bioengineering is there, microfluidics. So a lot of engineering domain, IITs, many startups, this device, diagnostics, kits, they are also coming up with this approach. So it is not like it has become into that area from microbiology, life sciences, biotechnology has more of shifted to molecular medicine, molecular biomedicine. These kind of departments have shaped up because molecular genetics is there. Different kinds of means, every now and then the biomedical science is there. So they all have clubbed it, all these new aims like in AIMS Bhopal and other departments. Post-COVID era, they have started these kind of medical science and technology departments, biomedicine. IIT Kanpur has opened up that Mehta Center for Family Medicine. IIT Kharagpur has opened. IIT Madras have their own medical college. So they are having lots of interest to, and government is also focusing on these pandemic preparedness, these research initiatives, how we should be Make in India, Discover in India, Vikasit Bharat, all these schemes. And since now I am associated with Department of Health Research, Government of India, and we used to have our meetings. So this, where I am working presently, also is an initiative by the Government of India, where they have tried to see that not only the elite institutes get to work with and do research. They have started to set up research units at medical colleges level. So what they do is they set up research units, they give funding for crores, 2, 3 crores to get your central facility instruments, then 25 to 50 lakhs for infrastructure to build a lab. Then they recruit staff like us to have scientists. And what our job is to bridge the gap between clinical practice and medical research because the clinicians, they have the access to patients, they have the access to samples, but they are not aware of how to use those samples for better research and better outcome. So they are involved in their practice. They because what is that they are directly in the contact with patient. They are getting to know about the trend, what are the like there is a more study on long COVID effect of vaccines are coming. So it is a long-term process. It will come after 5 to 10 years of COVID-19 infection or other re-emerging infection. So that will come up with many kinds of outcome. So for that, we have to be now. Cancer vaccines are coming. The HPV vaccine has come. So India is getting more into, and India is also known as a pharmacy hub, so generics and all, because we have to develop. So that is why they gave us a unit in all the major medical colleges in each state, 2 or 3 medical, and they said, okay, you do research, we'll be directly mentoring you, we'll be providing you all funds. And so we keep on visiting at about 3 4 months to Delhi. To I've been to Mumbai at NIRRCH ICMR in the month of May June. I was there. There was a training on precision medicine. So precision medicine is the new term that there is not one drug for all everyone. So you have to get the genomic insight of each and every person, their body, like their attitude, their genetic makeup is also different. So you have to give your drug or you have to give your food. Even precision nutrition is there now. Dietitian, nutritionists, they are also working. Diet, lifestyle, everything has come into place. So you cannot exclude anyone. Now you are taking each and everything. Mental health is also there. You have to devise also that into consideration. So likewise, it is on, and this is how I have shared my career for about 10 to 15 years. I'm working and constantly like exploring each and every day. I'm getting to know much more. Like I just believe that I'm a senior learner and everyone is others are junior learners. From me, more seniors than me are senior learners to me. So just the more I interact, the more I come to know that it is being evolving now. I'm more interested into this AI, and there are lots of software tools that are coming up. So the engineers are taking over the biologists. They're developing too much. So I'm working on it, seeing how it goes.
Yes, sir. Thank you so much. It was very inspiring, your journey.
So, we are now going to begin with the first segment of the interview. Given your background in medical microbiology, what do you see as the biggest challenge in infectious disease management in India today, beyond just the technical aspects?
Yeah, actually, what happens is that this infectious disease and what is the challenge? Like I told you that nowadays AMR is the worldwide threat, and due to the use of over-the-counter medicines and antibiotics, because what happens is that each and everyone and everyone known, they take medicines or these antibiotics readily. It is easily available at the counter. They used to take it there and use it. So, not the judicious use of these antibiotics is causing a lot of threat. They are causing resistance in the, I mean, these microorganisms, as well as resistance in the genes, and causing lots of side effects into the person as well. Apart from that, what I felt is that the need for surveillance and the need for not overlooking these infections. What happens at times is that we get a disease or we get a viral fever or we get any infection, we just take uh, you know take these antibiotics. They even though they don't know which antibiotic to take. An antibiotic is not for a viral infection, but
Yes,
many times doctors prescribe it for viral infection as well. So
yes,
that is how it is. It has become a common notion that whenever you get any infection or anything, you just take an antibiotic. Now, with the invent of gut microbiome and gut biology and microbiome studies, so these are also causing lot of disturbance into the gut biology of itself, dysbiosis. So not only it is causing issues with the disease or with the infection, it is causing lot of chaos to the other systems of the body, and they may cause fatigue, they may cause different, because the gut maintains your homeostasis and immunity. So that is how it is causing multi-organ, or it is causing a physiological level discomfort, and overall your quality of life gets to hamper. So for me, it is like the underreporting, the means the what we say is that overlooking overlooking anything, and being more judicious is what is the need of the hour. And you cannot say that particular disease is more important or this is virus. Only you have to focus on viruses or fungus or bacteria. Each and every disease itself can pose a threat, and you might not know what it can cause. So it is better to be alert and aware and surveillance, and early detection, early, because the more early we detect it, the more easy it will be for us to eliminate it from our population.
Yeah. So, moving on to the next question. How has the COVID-19 pandemic impacted the research and public health landscape for other infectious diseases like HIV/AIDS or tuberculosis, like you mentioned?
Yes, yes. Continuing from my previous answer, that is during the COVID-19 pandemic, whole of our this interest and our this attention went on to COVID-19 diagnostics and everything. So what happened was all these OPDs, everything got shut down, and under-reporting or under the diagnosis of many major diseases came, like the tuberculosis, where we had a plan to eliminate tuberculosis by 2027 or 2025. It got impacted, and now it has shifted 10 years more. It will take 10 years more, because during that time, the 60 to 70% less reporting of tuberculosis was done, because everyone was only focusing on COVID-19 pandemic. Nobody, cancers were not being treated, other diseases were not being treated. Everyone was just worried about COVID-19, and so what happened was that there was less reporting, less focus on other diseases, and what happened is that COVID-19 also caused these mortality in comorbid patients. That what happened is that many people who were having tuberculosis or HIV, these kind of, this COVID-19 went on to make a super infection, and that infection which could not be treated. Likewise, you can see some mucormycosis also happened, that fungal infection. So it became so much complex that it was not that the fraternity or the medical science was not able to figure out what is the exact uh, regimen to give to. Even now they are not focused. They develop the vaccine very fast, but they are not sure about this impact. What is going, like you might have heard also that some people were developing different symptoms. They were having long COVID. Few died. Every time the strain is different. They are having different symptoms. They are having different. So the health agencies and all these, they were just clueless of what to do, what not to do. So even now, at this juncture, we are not sure what exactly is the impact of COVID-19 and other diseases, or what it can pose in the near future.
Yeah.
Okay, so the next question is, how do you see climate change and globalization affecting the spread of infectious diseases? Okay, so the next question is, how do you
Yes, climate change in the past 5 years or 10 years has, due to this urbanization and lots of this deforestation, climate change has rose up significantly. This global warming is being done, industrialization, the temperature has risen. Now the winters, which were short, has become much more shorter. In our part, it's just 15 days to 21 month maximum. So what's happening is that this problem, and now you can see this time the floods are going on, the waterlogging, humid conditions, each and everything, they are making it more hard, congenial environment for these microorganisms to spread in the community. And with population on a rise, it can spread from human to human, animal, and like this COVID was happening, HMPV, Ebola, Zika, different kind of this zoonotic infections are also there from spillovers, because we are using animals. The other countries like China and also are using different animals for their food and fodder, and so the interspecies jump from animal to human, from plants to human. These kind of infections are coming due to this global warming and these environmental changes. Even now, the health agencies are including medical this health aspects or this climate change as a disease itself. One patient has died from climate change. So now they are including it as a separate thing for consideration. And with the rise of our use, that anthropogenic activities, microplastics, nanoplastics, these activities are going on. So people are this nanoplastics has been found in the blood also, in the fetus also. So these kind of activity with this, and the temperature is not having effect on these microplastics and nanoplastics. Even in our oceans, they are embedded. We cannot degrade plastics easily. So this is how this climate or temperature or this overall global environmental factors are contributing into the spread and resistance of those disease, and it is getting much and much tougher for us.
Right. So, moving on, your PhD work explored non-polio viruses in an era where polio is nearly eradicated. How important is it to keep surveillance for other enteroviruses that might silently spread?
Yeah, I told you earlier also that it was that I came and I luckily got to work on non-polio enteroviruses. So that's how I came to know that not only like that polio, since we were born, since I took birth, every you were also born. You might be hearing about polio vaccination, polio drops, pulse polio programs. So it is that we are quite familiar with polio, but we don't know about non-polio enterovirus because there are non-polio viruses like ecoviruses are there, Coxsackie B are there, different kinds of, they might be causing acute flaccid myelitis, acute flaccid paralysis, fecal-oral route transmission. Lots of things are there. But what happens is that as soon as we get into trouble with a particular virus or a particular disease, our whole focus shifts to that. And what happens is that we neglect other things that are also prevalent and equally important to get an attention. So for that, surveillance is very much important. Environmental surveillance, sewage treatment plants, sewage analysis is important where it is going into the table water or from fecal-oral route, it's going to transmit. So sanitation processes, what are going on. Government is also taking efforts in that, but government will not be able to work on it if we are not aware at an individual level. And as we are educated and we are learned, we used to make aware the public about these kind of things. So it's rather studying or doing research is one part, but to disseminate our knowledge in public by these kind of efforts which you all are putting, uh, we can use these things now. YouTube, Instagram, these things are quite prevalent. People keep on seeing, and general public is also aware. So these kind of interviews, these kind of things which you put, they may get involved into it and they may get much more aware of it.
Okay, so moving on to the next question. You studied H. pylori's linked to gastric cancer. Do you think infectious agents as drivers of cancer are under-recognized in India compared to lifestyle factors like smoking and diet?
Actually, what is happening is that now most of the diseases are multifactorial. They are not driven by a single factor. So you cannot say that it is only the infectious agent. Like what happened is when I took H. pylori as my case of study, it is a type 1 carcinogen by WHO. In 1994, it is declared by WHO that it is a potential carcinogen. And Barry and Marshall, and in the Western countries like Japan, South Korea, USA, they used to have smoked food and they processed foods too much. So they are having much more gastric cancer influence. But when we come to India, and India is having much more geographical climate, like the north is different from the south is different from the west is different from the east. Even in the north, they have different kind of temperature and environmental effects. And now talking to my place, that is Gangetic Plains, Uttar Pradesh, UP, then coming to Prayagraj, there is Ganga, Yamuna, Saraswati, Sangam is there. So we are having that water which is having bacteriophage. Our diet is also restricted to more vegetarian than compared to non-vegetarian. So these factors also contribute to the development of gastric cancer. So in our place, the gastric cancer is ranked 9th or 11th as compared to the northeastern state or southern states. There it is at the rank of under 5. So what happens is that the climatic conditions, the dietary conditions, the environmental factors, these are also taking. So that is how I tell you that in now I tell you about my finding itself, that H. pylori in my study was linked around 50%. It was not linked with cancer, neither it was linked with not having cancer. So it was like H. pylori caused ulcers. It caused peptic ulcer disease. It was having this kind of, but it was not having, even though the patients were having chronic infections from 10 to 12 years, they were having chronic infections of H. pylori, still they didn't develop cancer. They developed peptic ulcer disease. And same type of patient in eastern part of our country, like the northeast and Sikkim and Manipur, they developed cancer with a much more lesser prevalence. So what is the defining factors? That it is a multifactorial disease, obesity, different diet factors, everything. And yeah, talking about infectious biology, we are not concerned, like we have divided the diseases into two categories broadly. One is non-communicable disease and one is communicable disease. So what we think is that only those diseases which are widely known that they are communicable diseases, they are caused by infectious agents, are communicable diseases. But now what happens is since the invent of gut microbiome, whereas I was working on H. pylori, I came to know that there is a millions and trillions of bacteria residing in our gut. So there is Epstein-Barr viruses, there are different kind of viruses, they are having interplay with this and the. So what happens is that we are having good bacteria and the probiotics we take, we are having those also. So what happens is that we sometimes used to, that I told you now, that we sometimes used to neglect these factors. That okay, it is an infectious disease. The cancer cannot be a non this infectious disease, or obesity cannot be. But now it is coming to lot of interest about the gut microbiome, that the dysbiosis or the microbiome changes in the gut may lead to different kind of metabolism, because when we eat, the digestion inside our gut is done by the microbes. The immunity is made by the microbes. Even our skin means all, now there is gut brain axis, gut skin axis, different kind of axis are being studied. Even the gut is said to be the second brain, this kind of things. So lots of things have come into place with newer and newer research, and now they are linking each and everything with infectious biology. That yes, there are microorganisms that are responsible for producing short chain fatty acids, these metabolites, how they ferment. Fermented foods are a lot in the, like soy milk, tofu. Lots of these fermented drinks are available. They are only for this microbiome studies and microbiome level, and we are still in our early stages to make it confirmatory. But yeah, all these decisions, nothing can be neglected. We cannot say that one is more important than the other.
Right. So the next question is, since mushrooms have evolved complex metabolites to survive in microbes-rich environment, could these compounds serve as, natural models for antimicrobials that pathogens may find more difficult to develop resistance against?
Exactly. That's what my topic is. That there are many plants, medicinal plants, like we know from our tradition also, that neem is there, tulsi is there, other moringa oleifera is there, different kind of our Ayurveda is based on that only, different kind of medicinal plants. Uh, uh, we pray them, we respect them. Our tradition has told us that to conserve all these plants for our use. But what happens is that mushrooms are very much understudied, or most of the people don't even eat. They don't have this knowledge about mushrooms. They don't. So what happens is that mushroom is a macrofungus first of all, and that macrofungus, which is not causing infection, but it is used as a food. So what happens is that few mushrooms are very well known for medicinal properties. They are being sold for lakhs and crores of rupees. They are doing it like this. Uh, you know, there are Ganoderma is there, and other species which are being used at higher level. China and other countries are they are using. But what is the common mushroom which are like these mushrooms which are being eaten at our places? That was not much studied. People eat it, people enjoy it, but they don't know about the medicinal properties of those mushrooms. And the most important property of that mushroom is that they can synthesize vitamin D. And vitamin D is also due to these constructions of these means flat system and our exposure less towards the sunlight. So vitamin D and B12 is quite more means prevalent in the society, that there is a huge deficiency with females and others. There is that vitamin B12 and vitamin D. Even that is also becoming a silent pandemic, vitamin D deficiency. And vitamin D is very much important for immunity of our body. So vitamin D, D2 is highly prevalent in mushrooms. And if we put it in sun dried, it can become to the vitamin D3 form. So that is a good source of vitamin for our body. And the other essential elements, there are antimicrobial peptide, means there are n number of bioactive components. So when we take mushroom as a whole, it works synergistically. We are not sure that a particular compound is working on our ergostrol are there. I mean, in my study or in our study also, we found 38 to 40 compounds which were responsible synergistically, but we were not able to decipher which exact compound is causing antimicrobial or antioxidative effect. But what happens is, that is why we said that it can be a functional food, and it is posing prebiotic, probiotic, and postbiotic, all these effects. So what happens is that metabolites are, since we pluck this microfungus from the habitat where it is grown, so now it becomes a postbiotic because the uh, metabolites are stored in the body, fruiting body. Then what happens is prebiotic, because the outer core and the carbohydrate part is the prebiotic which goes and it becomes the feed for the microorganism. And probiotic, because it is a macrofungus, it behaves as a microorganism itself. So it is having all those properties. So I hope it will be much more researched and in future, and we can use it as a functional food.
Okay, so the next question is, do you think future wound care will shift from antimicrobial to microbiome modulating therapies, where the aim is not to kill but to rebalance?
Yes, exactly. That is the major shift or the paradigm shift in the later in the course of study during these times. Now, to kill or to destroy, that there is a word known as dysbiosis. That is why we are using probiotics, prebiotics. Now, there are, like, we are having good bacteria inside our gut. So, if we use antibiotics, that will kill the pathogens as well as the good bacteria. So, to restore the balance of our gut, or there are different kind of symptoms of leaky gut or diarrhea associated with antibiotics. So, to check that or to increase the efficiency of the drug, we need good microorganisms. They may also contribute in the efficacy of the drug, because there are certain microbes which will degrade the drug. So the bioavailability of the drug will not be as much possible. So to promote the good bacteria, there are two ways to promote the good bacteria. One is to take live bacteria directly as probiotics. And the other way is that if there are few good bacteria, let them grow and multiply in number. So that is why when we take a drug nowadays, it is having pre and probiotic, both are involved in it. So prebiotic is the food for those bacteria which are living inside our body, and probiotics are the live bacteria or the beneficial strains of those bacteria, which will be. Then it came towards the postbiotic. Now, what postbiotic is that you don't take pre or probiotic, you directly take that compound or that essential bio component which is responsible for producing the desired effect. So we are directly taking the product of those bacteria which they are synthesizing. So mushrooms is having all those things, and to maintain this process of microbiome, it is shifting down. The skin and wound healing processes are going on. The oral application of probiotic strains are being given. There are Saccharomyces cerevisiae, fungal-based probiotics are also there. So it is much more into preliminary stage, and day by day they are getting into some startups are there. They are producing it artificially, and they are working on it day by day.